You know those rides that give you such a thrill?
Five, four, three, two, one, scream!
The ones that make you scream to the top of your lungs? Well, have you ever wondered about the calculus behind them? No? Same. You only had to because of this project.
The development and workability of a roller coaster, which involve the speed, acceleration, slope, and maximum and minimum height, are all found through the application of calculus. Obviously, the purpose of this is to provide safety for the people riding these roller coasters. Without the application of calculus, a roller coaster would not be able to complete its course or operate as expected.
When constructing roller coasters, calculus is used by engineers to precisely calculate the curves, loops, and twists on a roller coaster. Calculus, with the help of physics, allows engineers to predict the speed of the roller coaster at a given height and slope. This makes sure the roller coaster speed is safe and will determine how fast it is going at a certain point. When engineers create hills and valleys, they have to take into account the acceleration of the roller coaster.
Here's an example of how calculus is applied.
In order to find, for example, the velocity and acceleration at which the roller coaster is moving at its peaks and valleys, calculus is used. The example function of the graph of 0.3t cubed minus 5t squared plus 21t will be used to loosely resemble this roller coaster. This is the graph of the roller coaster's position. Since the derivative of any position function is its velocity, we must derive the function, giving us the function 0.9t squared minus 10t plus 21. Factoring the velocity gives us critical values, which are only candidates for zeros of the function. A simple first derivative test will confirm that the critical points, x equals 2.8 and x equals 8.3, are in fact maximum and minimum values for the function respectively. The same principle of deriving, factoring, finding critical values, and performing the first derivative test to find maxes and minimums can be applied onto the velocity function in order to find those values for the function's acceleration. For the sake of time, only the maximum's properties are calculated. By just plugging in the maximum's x value into the x values of each function, their values are calculated. At the maximum 2.8, the roller coaster's speed is 26.2 meters per second, its velocity is 0.56 meters per second, and its acceleration is negative 4.96 meters per second squared.
In conclusion, calculus is a crucial part of the designing of roller coasters. It is used to notify engineers of speeds, velocities, etc. at many different points along the track. This information is used to make sure that all passengers are safe when they ride and make the ride enjoyable.